Good afternoon and welcome to cross-multiplying problem type 3, where we're going to come up with two different answers for each of our sets of ratios. So first we have x over 2x minus 9 equals 5 over x minus 4. And like we've been doing before, we're going to cross-multiply. Multiplying the top and the bottom. That side times top and bottom of that side. So I'm going to rewrite this so I don't have any fractions. X minus 4. And that's going to equal 5 times 2x minus 9. Now, the first thing I have to do is distribute the x into the things that are inside. So that's going to give me x squared. I'm going to distribute that part. So I'm going to get minus 4x equals, I multiply these parts together, I get 10x. I multiply these parts together, I get minus 45. Now I want to have everything on one side, so my x squared part is positive, or whatever letter I have squared is positive. That makes it easier to factor. So we're going to move this 10x to the other side by subtracting it. And we're going to move the 45 to the other side by adding it. Plus 45. So now I have x squared minus 14x plus 45 equals 0. Now it's important to the fact that you have it equal to 0, because if it's not equal to 0, you could factor this, but you wouldn't be able to solve it. We're going to solve it. So let's set it into two sets of parentheses. When we have an x squared part, we have to multiply things together at the front that give us x squared. Now we have to think about what multiplies together to give us 45, but adds together to give us a negative 14. If I think about the factors of 45, I could do 9 and 5. 9 and 5 would give me 14, so since I want a positive 45 but a negative 14, I'll make it a negative 5 and a negative 9. Because if I FOILed this out, I'd get a positive 45. My inside and my outside term would give me the negative 14. So now I'm going to take each part and make it equal to 0. I'll do that over here. So x minus 5 equals 0. And x minus 9 equals 0, because we're trying to determine what the root is of these equations. So I'm going to add 5 to both sides. So x equals 5. And here we're going to solve it as well, so we're going to add 9 to both sides. And we're going to get x equals 9. So in this answer, you're going to have both 5 and 9 as possible answers. Let's try another example. Here we have a negative x over 3 equals 3 divided by x minus 10. Again, we're going to cross multiply. So a negative x times x minus 10 is equal to 3 times 3. So if I distribute this, I'm going to get a negative x squared. If I distribute this, I'm going to get plus 10x. If I take 3 times 3, I'm going to get 9. Now, I want to have everything on one side, so my x squared part is positive. So that means I'm actually going to move everything over here to the right. So I'm going to add x squared to both sides. And I'm going to subtract the 10x from both sides. So now, this side on the left is going to be equal to 0. And my x squared isn't going to combine into anything, so I'm going to put that first. I'm going to do the negative 10x, and then plus 9. Now, you'll notice that I've written this in decreasing order of x. I've done the x squared part first, then the x, and then the no x. That way I can actually factor it. So let's look at factoring this quadratic equation. We want to think about what multiplies together to give us 9, but adds together to give us a negative 10. Well, if I take a negative 9 times a negative 10, or a negative 9 times a negative 1, that'll give me a negative 10. So I'm going to put that back in, a negative 9 and a negative 1. And in the front I'm going to have my x. So if I look at my inside term, that would give me a negative 1x. My outside term would give me a negative 9x. If I added them together, I'd get the negative 10x for my middle term. If I take the negative 1 times the negative 9, I'll get a positive 9. So now I need to take each one of these sets of factors and make them equal to 0. Take x minus 1 equals 0, and x minus 9 equals 0. You need to find both because both of them are reasonable factors. If I add 1 to both sides, I'm going to get x equals 1. And then if I add 9 to both sides, I'm going to get x equals 9. So I get two answers, x equals 9 and x equals 1. Let's look at another example. Here we have a negative 5x plus 5 over 24 equals a negative 1 over x. Again, I'm going to cross multiply. So if I take negative x plus 5, now I'm going to put that inside a set of parentheses and put the x next. And that's going to equal 24 times a negative 1. So when I multiply this together, I'm going to distribute this x. So I'm going to get a negative x squared. Then I'm going to distribute this 5. So I'm going to get plus 5x. If I take 24 times a negative 1, I'm going to get a negative 24. Now, I want to get everything on one side, so the x squared is positive. So I'm going to add x squared to both sides. And subtract the 5x. So I'm always doing the opposite of whatever the operation was. So over here, I'm adding x squared, and I'm subtracting 5x. Now I have 0 on the left side, again. I'm going to put the x squared first, minus 5x, minus 24. So now I'm going to get 0 equal to, and make my two sets of factors. I know what will multiply together to give me x squared. An x and an x. What multiplies together to give me a negative 24 but adds together to give me a negative 5? If I think about a negative 8 and a positive 3, my middle term would be 3x, my outside term would be a negative 8x, and then 3x minus 8x gives me the negative 5x, which is what I wanted in the middle. And a positive 3 times a negative 8 would give me the negative 24. So now I have my two factors. I have to take each factor and make them equal to 0 to figure out what my roots are. So here I want to get the x by itself, so I'm going to subtract 3 from both sides. I'm going to get x equals a negative 3. And I'm going to get the x by itself on this side, add 8 to both sides. So now I have the root of negative 3 and positive 8. And those are examples today for cross multiplying. This is problem type 3. I hope you have a wonderful day. Bye-bye.